In today's video, we shall see the detail about Vernier Caliper. So the Vernier Caliper is a very important instrument and it is very much useful in engineering as well as physics for doing different kinds of measurements. So all these detail we shall see in this video. It is a masterpiece of engineering and mathematics, how it works and everything about this we shall see here. So first of all, so this is the title of the video, that is Vernier Caliper, a complete guide in one video. So first of all, we will see introduction about it, then we'll go to the principle and working, then practical, then errors and mistakes, then advantages and limitations. So all those things will be there in this one video. So let's begin. So it was invented by Pierre Vernier in 1631. So this is the Vernier caliper. Now basically a Vernier caliper is nothing but what? There is a scale which you have in your geometry box or compass box. So that similar to that we have this scale from 0, 1, 2, 3, 4 centimeters. Like that we can have up to say 15 centimeters, and in some cases it may vary. So this is a centimeter scale here, the below one, and so this scale we call it as a main scale. So this is main scale, and there is a sliding scale is attached to it. Now this sliding scale is very important because it divides 1 millimeter into 10 parts. So how it divides 1 millimeter into 10 parts we shall see in the animations in the coming up part of this video. So this is called as the sliding scale, which is called as a Vernier scale. Now with the help of this same instrument, as I had told you in the earlier part, that it is the genius masterpiece of engineering and mathematics. So we can do the outside jaw can be used to measure the outside or the external dimensions of an object. Then these inside jaws over here, they are used to measure the inside diameter or maybe inside dimensions rather, that will be more specific, of an object. And this tail is useful to measure the depth of an object. So all those things also we will see in the practical in the coming up part. Now to understand the principle and working of a Vernier caliper, so basically it is a scale which you have in a geometry box actually, and to that we have attached a Vernier scale, which will be a moving scale. So first of all, this is the main scale. Now I had zoomed out this so that you can see it becomes easily visible. So in this part I had zoomed out, they are not up to the scale, but for understanding purpose it will be very good because you can easily read these things. So here we have 0 centimeter, 1 centimeter, 2 centimeter and so on. So this is our main scale. Now main scale is divided into 10 parts here. So this is divided into 10 parts. Therefore each part in the main scale will be nothing but what? Say from 0 to 1 centimeter we have 10 parts. So it will be nothing but what? 1 centimeter minus 0 centimeter divided by 10. So that comes out to be equal to 0.1. So that means what? These each divisions over here will be of 0.1 centimeter. So from here to here it is 0.1 centimeter. Here to here this much distance will be again 0.1 centimeter only. But so if we start it from here 0, so it will be 0 centimeter, then this will be 0.1 centimeter, 0.2 centimeter, 0.3 centimeter and so on. Then after 1 we have it as a 1.1 centimeter, 1.2 centimeter and so on, like that. So now to this there is a Vernier scale is attached to it. Now Vernier scale is actually very genius scale. So with the help of Vernier scale we can divide the measure the very precise measurements. So how that is possible, that also we are going to see in this video. So in case of a Vernier caliper, so this actually generally we have 10 divisions are there here. From here 0 to 10th division on the Vernier scale are there, but these divisions are in such a way that they are one division less. So that means what? In 9 divisions of this 0 to 0.9 centimeter, we have divided this into what? 10 Vernier scale. So therefore what will happen here? These will be 0.1, 0.2, 0.3 like that up to 0.9 and 1 centimeter, and up to here only there will be 10 divisions up to 0.9. So our 0th division is at 0 centimeter for the Vernier scale, and the 10 number division will be at 0.9 centimeter. Okay, so it is 9 millimeter, or it is nothing but what? 0.9 centimeter. So 10 divisions, they correspond to 0.9 centimeter. Therefore, one division will correspond to 0.9 divided by 10. So if we divide 0.9 by 10, it will be nothing but what? 0.09 centimeters. So that means each individual division, the distance between the consecutive individual divisions will be nothing but 0.09 centimeter. So that is what we have here. This is 0 centimeter. Then we have 0.09 centimeter. Then there will be 0.18 centimeter, 0.27 centimeter, 0.36 centimeter, and like that we go up to 0.9 centimeter. So 10 divisions, they are nothing but what? Divided into only 0.9 centimeter part. Okay. So actually they are nothing but what? You have to read the table of 9 after 0.09 and just you have to read the table of 9. So you will get all these 10 divisions over there. Okay. Now to find out the least count of this, the formula for the least count is nothing but what? 1 MSD means 1 main scale division minus 1 VSD means 1 Vernier scale division. Now if you see here 1 main scale division, so I will start from this 0 to 0.1 centimeter. So 1 main scale division is nothing but 0.1 centimeter minus 1 Vernier scale division from 0 to 0.09 centimeter. It is nothing but 0.09 centimeter. So 0.1 centimeter minus 0.09 centimeter. So it comes out to be 0.01 centimeter. Now this is least count. What is least count? Least count is nothing but the smallest possible thing we can measure with the help of a particular instrument. Now here with the help of Vernier caliper, we can measure the smallest thing as 0.01 centimeter, and this we can do only by attaching this Vernier scale. That is why I told you that this is the genius part or genius masterpiece of engineering and mathematics, because otherwise if you have the scale in your geometry box, we can have the least count of 0.1 centimeter. But just by attaching this Vernier scale, we can measure 0.01 centimeter minimum least count. That is the least count minimum we can measure with the help of a Vernier caliper. Now, so I will just show you different readings. The formula for the total reading is nothing but what? MSR means main scale reading plus Vernier scale reading multiplied by least count. Now, if our Vernier caliper is very perfect, that means what? When both the jaws are closed of the Vernier caliper, then the 0 of Vernier and 0 of the main scale and 0 of Vernier both exactly match. Then in that situation, when the jaw is closed, then what will happen? The main scale reading will be 0. So this is main scale reading, and that is 0.0 centimeter, and the Vernier scale division will be nothing but again 0 only, because this one is there. Okay, so 0. So then it will be 0 multiplied by 0.01 centimeter is equal to 0.00 centimeter. So when the jaws are completely closed of a Vernier caliper, then it should have 0.00 centimeter. That is obvious because it should start from 0 for the best Vernier caliper which is working properly. Okay. Now in some books or in some other books, we may have this MSR, we call it as a small a, and VSD, we call it as a B. So don't get confused. Just to specify their name properly, I had given them over here. Now, if you just move this slightly, then what will happen in this case? The main scale reading. So to measure the main scale reading, what we have to see is where is the zero of Vernier scale. Now see, this is zero of Vernier scale. Just before this, whatever is there, that is our main scale reading. Now in this case, just before the Vernier, zero of Vernier, there is 0 centimeter of what? Main scale. So therefore our main scale reading in this case will be 0.0 centimeter. And the Vernier scale division, we have to see which line is coinciding properly. Which line is coinciding properly. Now here our first line of the Vernier scale is coinciding over here. So therefore our Vernier scale reading will be nothing but what? 1. Vernier scale division will be 1. So it will be 0.0 centimeter plus 1 multiplied by 0.01 centimeter. So it comes out to be equal to 0.01 centimeter. So this will be the measurement of for this particular reading. Now if we slightly move it again, then in this case what happened? Again our main scale reading will be 0 only. Vernier scale reading will be 0, 1 and 2. So Vernier scale division will be 2. So it will be 0.02 centimeter. Now similarly, if I move it again, then it will be main scale reading 0, Vernier scale reading 0, 1, 2, 3. So it will be 0.03 centimeter. I will show some other reading. Say now in this case, just before the 0 of Vernier scale, we have 0.9 centimeter. So it means our main scale reading is 0.9 centimeter. And the line coinciding here is the third line. So the line coinciding here is 0th line, first line and second line. So second line is second division of the Vernier is coinciding. So therefore this will be 0.9 centimeter plus 2 multiplied by 0.01 centimeter. So it comes out to be equal to 0.92 centimeter. Now we will see some practical demonstration in which we will see how to measure the outer diameter, inner diameter, or say rather to be more specific, the outer dimension, inner dimensions, and as well as depth of an object. So all those things we will see here in the practical demonstration. So here I have already recorded this video for measuring the outer diameter of this ring. So for that purpose we have to use these two jaws. So they will be useful for measuring the outer diameter of this ring. Now we have to properly align it over here, and after aligning it properly, we have to see the main scale reading and Vernier scale reading. Now you can see here the main scale reading is at 7.6. See here, this is 7 now, and the main scale reading just before the 0, I had just made it here in the animation. So it is just before this, it is 7.6 centimeter is our main scale reading. And if you see the Vernier division, which Vernier division is coinciding, then this one is the coinciding Vernier division, and this is nothing but what? 7th division of the Vernier scale. So main scale is 7.6 and this is 7. So therefore our total reading for that is the outer diameter of the given ring will be 7.6 centimeter plus 7 multiplied by 0.01 centimeter. So it comes out to be 7.67 centimeter. So this is the outer diameter of the given ring. Now we will do the inner diameter measurement. Now for inner diameter measurement, we have to use these two jaws over here, which are shown here, these two upper jaws over there, and we have to adjust this properly here so that we get a proper reading here. Now after adjusting this properly over here, yeah, you can see here this is about just above 5, so I think it is 5.4, and the Vernier division coinciding over here is 4th division. This is 0, 1, 2, 3 and fourth one is coinciding. So I will just here show in the animation. So just after 5, this is the fourth one. So it will be 5.4 will be the main scale reading, and the Vernier division coinciding is 0, 1, 2, 3 and fourth one. So therefore the total reading will be 5.4 centimeter plus 4 multiplied by 0.01 centimeter. So it comes out to be equal to 5.44 centimeter. Now we will do the depth measurement. So for depth measurement, I have this video. So we have to use this tail over here for doing the depth measurement. This tail we will be using to do the depth measurement. So we have this object here. So we will find out how much is the depth of that object with the help of a Vernier caliper. Now see here, we have to properly adjust it first. So I think it is, yeah, we have to properly adjust it first and then we will see it. So see here, this is just before the 0 of Vernier, we have 0.9 centimeter and the division coinciding here is the 7th one. So I will just show here in this animation. So this is 0.9. So 0.9 will be our main scale reading and our Vernier scale reading is nothing but what? 7. So the total reading will be 0.9 plus 7 multiplied by 0.01 centimeter. So it comes out to be equal to 0.97 centimeter. Now this is all about measuring when the instrument is very proper and it is properly calibrated and so on. But what happens if our scale or our instrument, that is the Vernier caliper, is not properly calibrated? In that situation, we have to handle different errors and mistakes. So we should know what are the possible errors and mistakes. The first most common and most error, which is called as a zero error. Okay, so first of all, whenever we have this Vernier caliper, we have to remove this zero error. Now how to remove it? First we have to check whether there is a zero error or not, and then if it is there, then we have to add or we have to subtract the error from the main the reading, the final reading, to get the error-free readings. Okay. Now, if the Vernier caliper, when the Vernier caliper, both the jaws of the Vernier caliper are closed. Okay, when in the closed situation, if the main scale 0 and the Vernier scale 0, if they are coinciding properly without any misalignment, then what happens? There is no zero error in that case. So the formula for zero error is nothing but what? Vernier scale division multiplied by least count in this case. So it will be 0 multiplied by 0.01 centimeter. So it comes out to be 0. So that means what? 0 centimeter rather. Okay, it will be. So there is no zero error in this situation if both are properly aligned. Both jaws are properly aligned. Now in some cases what happen? The both jaws may not be properly aligned. Okay, so what may happen? Say the Vernier scale jaw is towards the right side, suppose. So if the Vernier scale is towards the right side of the main scale, we call it as a positive error. Okay, now in this case, you can see here the Vernier scale is towards the positive side here. Now we have to find out whatever is the error here. So in this case, since the fifth line, see here the fifth line is coinciding here. So therefore, Vernier scale division multiplied by the 0.01 centimeter, that is the least count. So it comes out to be equal to 0.05 centimeter. So this reading, that is 0.05 centimeter with plus sign, we have to subtract from the final reading to get the error-free readings. Okay. Now next we will see the negative error. Now in case of negative error, actually what happened? The Vernier scale is towards the left of the main scale, the left of the 0 of main scale. So in this situation, actually we have to count these Vernier scale division from right to left, So that means this 10th division will become the 0th division, then 9th will become 1, then eighth will become second, and the seventh will become nothing but what? Third division. Okay, so this we can do. Or what we can do is to find out the negative zero error. Still there is a simple thing we can do is whatever we are counting for the other things, same counting we will do. That means we will do it from 0, 1, 2, 3, 4, 5, 6 and 7, and we have to subtract that from 10. So here the formula for the negative zero error is we have to attach a minus sign because it's a negative zero error, and therefore it will be 10 minus Vernier scale division. So here the 10 minus Vernier scale division is the 7th division multiplied by least count. So if you do these calculations, you will get it as a minus 0.03 centimeter. Now from final reading, we have to subtract the error. Maybe it is a zero error, so that means what? There is no error. If you subtract that, it will be the reading will remain the same. If it's a positive error, the reading will decrease because already the scale was towards right side. Therefore, the final reading has to decrease. So if it's a positive error, the reading will decrease. On the other hand, if the negative error is there, the final reading we have to subtract, but the final the error is nothing but what? The error we have to subtract, but the error is minus 0.03 centimeter, and if you subtract this minus 0.03 centimeter, it is as good as adding this 0.03 in the final reading, because that much more reading will be there because the scale is shifted already towards the left side. Okay, so this is what we call it as a zero errors. Actually, they are very important as far as measurement are concerned or exams are concerned. Everywhere they are very important, so you have to be careful. You can see it again and again if you want to understand it again in a proper way, or you can ask me in the comment also. Okay, now we have other errors possibles are nothing but what? Parallax error. Now see, whenever you have a Vernier caliper, you have to just see it perpendicular to that. If you see it from the right side or left side, so if you go like that, then what will happen? There will be some Vernier scale division coinciding will be some different. So you have to be careful while doing these readings that you should not have this error due to parallax. You have to see just perpendicular to that scale. That means main scale and Vernier scale. Now next thing is nothing but what? Instrumental error. It may happen due to the wear and tear or the poor manufacturing or damage of the jaws. So we have to regularly calibrate it to avoid this error. The other error is nothing but misalignment or improper contact. Jaws may not be in contact. So we have to ensure this initially whether these jaws are proper or not. Then next error is nothing but temperature error. Now although the effect of temperature will be very small amount actually, but in some, if the variation in the temperature is very large, say for example, some days there is a 10 degree centigrade temperature and some days there is a 50 degree centigrade temperature. So there will be approximately 40 degree centigrade difference. So you know that the Vernier caliper is made up of nothing but what? Metal. So it may happen that due to temperature, there will be slightly expansion. If it is a higher temperature, there will be expansion. If the lower temperature, there may be contraction in the total scale of the metal. So that also we should be careful. So we have to be careful that we have to measure the readings at room temperature, maybe at 25 degrees centigrade. And the next is nothing but what? Reading calculation mistakes. So these things actually there is nothing to do with the instrument, but while doing the calculations we have to avoid all these mistakes while doing calculations by multiplying it by 0.01 centimeter, that is the least count, etc. So we have to be careful. Now what are the advantages? The advantages are nothing but high accuracy, because just by attaching a Vernier scale we are dividing 0.1 centimeter into further 10 parts. That means we are dividing 1 millimeter into 10 part actually very easily. Okay, so that is the main advantage, and it is giving a very good accuracy, and it is a multi-purpose. We can do the three-way measurements which we have already seen. we can do the outer dimensions, inner dimensions and depth of an object. And what are the limitations? It is prone to parallax, so we have to be careful while taking the readings, and it needs a careful handling. If you don't do a careful handling of this, it may start malfunctioning, or sometimes it may give the wrong readings actually if it gets damaged. So this is the explanation of the Vernier caliper in detail. I hope that you understand it. Do like, subscribe and share. Thank you very much.